Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing the GFG Weekly Coding Contest 101. So, there has been a little bit of delay because a little bit of rain has happened in Noida this eve, and the Wi Fi was down for around 20 to 25 minutes. And after just the Wi Fi came, I came back online in 3 minutes. Okay, sorry for the delay, can't help it due to climate change. Okay, fair enough. So the very first, let me talk about the overall idea of this problem. The very first problem was a problem which can be detected that yes, this can be solved using a very well-known technique. And it was easy to guess. Why? Because if you had already solved equilibrium point question, then this question was very easy for you. If you had solved, else this question wasn't easy. Okay. Now, the very next problem is like, which was the third problem? Friendly match. Yep, the very next one is that Geek's new game. First, it seemed to be a game theory problem, and every at each turn, everyone would take one bit, and everyone would take one bit and others then they both would try to maximize. First it seemed, after reading the question, like first 2 3 lines, it seemed like this problem is of game theory's NIMS game. But then when you move forward, you would understand that NIMS game or game theory idea is not at all required to solve up this problem. Okay. Then the very last one also seemed to be a game theory problem, but these problem had specific cases, like the number of cases were absolutely very less. First it seemed like yes, I need to use recursion a lot. Then we find out that the use case of recursion is a little bit less, and the implementation is a kind of bit long. So last question was a lengthy problem. The second question was a greedy problem. The very first problem was a prefix sum problem. And the prerequisite of attempting this whole contest together was recursion for the last problem. For the second problem, it was greedy with the idea of priority queue. The very first problem was just prefix sum. Okay, fair enough. If you don't know either of this, you can move forward. So give me a quick one if you are present in the stream. So now let us start presenting it. Share the screen window and this should be, yep. Yeah. Okay, so now let me just take the first one. Mhm. Just let me add it to clipboard. Okay, this is done. Okay, so now here we are given the first one. Like, let me just draw it. Okay, so in this problem, let me just write down the problem itself. I think this is not necessary. Okay, so in this problem, we are given an array. given an array, okay, and then it contains, so okay, so we are given that the input is around 15. Okay, let me just check the comment. Where can I create a vector for question 2 and solve edge cases were all required if are same in the array? Some cases, if all elements are required, can I create a vector of pair for question 2? Which is question 2? Uh, yep, you can use a vector of pairs also. You can use vector of pairs to solve this question also, and it would be good to go. Okay, so here in this, you are given an array. Just a board not visible. Okay, board is not getting updated. Let me just see the board itself. Yep. Okay. Okay. Board not visible. Okay, just, yep. Now it would be visible. Okay. So here we are given an array, and then we need to construct a binary array in the result itself. So the idea is the output should be a binary array. This is what is your output. Now the very next thing is that a binary array, as the name suggests, consists of zeros and ones. So now the case for one is, this is case for 1. The case for 1 would be if the sum of its left and right view, okay, is based on the sum of its left. If the sum on the left side and the right view of the array is even, if the sum of the left side and the right view of the array is even, if the sum of the left side, sum of left side is even, this is the case 1. Now for case 0, okay, if the sum of the left side is 0, okay, if the sum of the left side is not 0, so I can say that the sum of the left side is odd itself. If the sum of the left side is odd, then we would do it, else it would be 0. Okay, fair enough. Now what we can do is, if we write up this thing, the array inputs are 1, 3, 5, 1, 3, 5, 6, 7, 9, 1, 3, 5, 6, 7, 9, and here for this it is 1, 1, 1, 1, and it is 0, 1, 1. Okay, so now why it is like this? If the sum of its left, if the sum of its left and right view of the array excluding the current element, okay, so if the sum of the left side and the right view is even, okay, so sum of the left side is what? So if I just talk about the very first one, the sum of the left side is 0. Okay, sum of the left side is 0 and the right view is 1, 2, 3, 4, 5. Okay, So as it is 0, so 0 is considered as an even number, so it would be 1. Okay. For 1, the sum of the left side is 0 and the sum of the right element is 30, hence the value is 1. Okay, so we need to sum all this up. So if we sum up 3 plus 5 plus 6 plus 7 plus 9, the sum would be 30 itself. That is why here the sum is 0 and here the sum is 30. So in reality, what we need to write is, let me just remove the annotations. Yep, this is all that is required. If I remove of this annotations, I can say that the sum of the left side is even as the sum of the right side is also even, so the value would be 1. Now let us consider for 3. Okay, sum of the left side, the sum of the left side and the right view of the array is even. So now for 3, sum of the left side is 1 and the sum of the right side is 27. So if you just see this value is 1. Okay, so I would say this is 1. This is what? Left side. Okay, this is left. And let's talk about the right one. So 6 plus 1, 11. 11 plus 7 is equals to 18. 18 plus 9 is equals to 27. Is equals to 27 on the right hand side. So 27 plus 1 is equals to 28. So the value is even. So the value would be 1 itself. Okay, this is done. Now 1 plus 3 is equals to 4. Now I will just remove this part. Am I audible? Just let me see. Did test case have n is equals to 0? So is the blackboard visible? Someone is telling blackboard is visible, but on my end it is showing that it is visible. So quickly tell me if this blackboard is visible or not. Till then I'm just solving it. So 3 plus 1. So the left side value would be 4 itself. Okay, and the right side value would be 6 plus 7 is equals to 13. 13 plus 9 is equals to 22. 20, even added with even is equals to an even number. So the sum for this would also be 1. Would also be 1. Now let us see for this. So 5 plus 3, 8. 8 plus 1 is equals to 9. So the sum on the left hand side is 9 itself. And the sum on the right hand side is also an odd number. That is 9 plus 7 is equals to 16. Okay, sorry, it is an even number. So is equals to 16. So 9 plus 16 is equals to 25, which makes it an odd number. So that is why the value to this is 0 itself. Okay, I would again clear all this. And then again, I would say the sum on the right hand side is 9. So I would just say 9 itself. Then sum on the left hand side, what it is? 6 plus 5, 11. 11 plus 3 is equals to 14. 14 plus 1 is equals to 15. Okay, is equals to 15. 15 plus 9 is equals to 24. So the value is a even number. Now we move forward and we say that what would be the value? Like, let me just show you. Yep. See, for 9 on the right hand side, the value is 0. Okay, so for right hand side, the value is 0. Okay, for the left hand side, the value would be 7 plus 6, that is 6 plus 7 is equal to 13. 13 plus 5, 18. 18 plus 4 is equals to 22. So 22 plus 0 would make it even. That is why the output to this is this one. Okay, do I make sense? So now the idea is very simple. What you need to do is, suppose you are at a current index, you are at a current index I. Okay, let's say this is I. Okay, so now what you need to do is you need to start from 0 till the value of I minus 1 at this side. And then that side, what you need to do is you need to have like, let me just change the color, it would make more sense. Yep. So this side would be I plus 1, okay, I plus 1 till the value of n minus 1. Okay, the very first one was this one, this value, and then this value, and then this value. Okay, so for each index I, you need to traverse on the 3 parts. This is what you need to do. Okay, now the question is that if I try on, like, for one index, I start a loop, like ignoring one element, I am iterating on the whole. So I can say that for one element I am doing n minus 1 operation. So I can say that for n elements, multiplying n on both sides, it would be n square minus n. Okay, so I would be doing n square minus n operation in total. Okay, so n square minus n, the value of n is what? If you observe, the value of n is 10 to the power 6. So even if it is n square approach, then 10 to the power 6 square is equals to 10 to the power 12, which is greater than 10 to the power 8. So it would give you a time limit exceeded for sure. So I need a better approach for this. So going a bit slow. Yep, because many people who are not able to understand, if you are able to understand, I should go fast. So I wish there was a 2x button for live stream. Okay, fair enough. I'm just speaking slowly so that people would understand. So now, in this question, see, this editorial is for the people who were not able to solve the first question. So they would require a bit of patience. Okay, so now let's say I need to operate on sum and it's a static array. Okay, and the array is a static array. So I can say that I can simply use a prefix sum approach for this. Okay, which would tell me the sum from the left to the right part. Okay, if you don't know prefix sum, consider going back and understanding what is prefix sum. Now I would move forward to the implementation, how the whole idea of prefix sum came into picture, how what is and how all is coming up. So yep, so now prefix sum, but is there a better approach than this? Yes, a kind of better approach than this is there. What a better approach would be that instead of I can build out the prefix sum, I can query lnr for each one and I can do it. But instead of that, what I can do is, as I know that I only want the sum for once. So suppose this value is 1, this value is 2, 3, 4, 5 and 6. So 6 multiplied by 7 divided by 2, it would be 21. So what I can say is the sum is 21 at this step. Okay, and this would be considered what? This would be considered as the right sum. So the right sum for the first element is this one, and for the left sum, this is 0. When I would come to the first element, I would subtract 1. So this would become 20. Okay, so now I have 0 and 20. This is for the very first step. Then I would go to this side and I would add the previous value. which was 1, and I would subtract 2, which was 18. So see how am I getting the left and right at each step. Then I would be moving forward to 3, would be adding 1 plus 2, that is 3, and would be subtracting the value of 3 from it. So it would become 15. See, 6 plus 5, 11, 11 plus 4 is equals to 15. Now, again, I need to add this 3 at this position. Okay, this 3 at this position. So 3 plus 3 would make it 6. And I need to subtract the value of 4, which would make it 11. So see how we are getting the 11. So in the next step, okay, in the next step, I would add up. So I would remove up this 5, okay, and this I would remove up this 5, that would make it 6, okay, and I would add up this 4, that is make it 10. So 4 plus 3, 7, 7 plus 3 is equals to 10. So see how we are getting up this. So this is how, with the help of, and this idea is known as running sum. So how with the help of this, I would be able to conquer this. Actually, I too want to say that kindly move forward with this, but it won't be helpful for everyone. No? People who came to, like people who were not able to solve this would be seeing this question for sure after the stream. So I'm just helping them with everything. Okay. So initially the sum is 0. So first I would take out the sum of the whole array and it would be considered as the left sum. Okay. For int I is equals to 0, I is less than n, I plus plus, and I would say sum plus is equals to a of I. After this is done, I would say vector of answer. So I would have vector int of answer of size n. Okay. Now I would start iterating from the first element to the last element, and I would make each of this as the spinal cord. So now I would say if the sum minus a of I, okay, this would be the left one. Okay, if the sum on the left one, right, modulo 2 is equals to 0. Okay, then I would say answer of I is equals to 1. Okay, else the answer of I is equals to 0. Okay, and then we would return the value of the answer. So now let me just compile and run and see how many errors are we getting. Okay, seems like we are not getting any errors. Okay, so now you would be amazed to see that earlier I was talking left plus right, then if it is even, then the answer would be 1, else the answer it false. Okay, but here we are just considering the right hand side or the left hand side. Only one is considered. We are not considering the sum, but still we are getting a correct answer. Is there a problem with the backend code? No, it is not. Why? Because I can say that even plus odd would be odd only. Okay, even plus odd would be odd only. Even plus even, okay, would make it even, and then odd, okay, even plus even, and then if this value is odd plus odd, then only this value would be uneven value. That is why we can only consider this. And you can consider both of them if you are not able to understand it, and that would be also fine enough. Everyone is waiting. Question 1 is sum of an index. Yeah. Okay, so now I would be moving forward to the next problem. Binary array, and this is GFG's new code. Okay, so initially here in this question, if I just remove up everything, Okay. Now, here we are told that you would be doing a certain task and then you would be earning some of it. So, like I can say, a scam is going on. Okay, let's say a scam is going on in the market. Okay, a scammer is going on in the market and he is claiming that if you buy a package of 10 rupees, you would be earning something out of it, that is 15 rupees. Okay, let's say. So let me just make this a little bit this side. Yeah. Okay, this is. But in this scenario, I he like a scammer claims to me. So my friend came to me and he asked me that is this scam correct? Is this scam valid? So I told him that if you invest 10 rupees, you won't be getting 15 rupees. Rather, your money would be lowered down to a value less than 20 rupees. Like whatever you invest, you would be getting less than that. Okay. This what happens. Okay. And this is in the question that if you complete a particular task, okay, if you complete a particular task, okay, by investing X, then you would be getting a reward of less than X. Remember that. This is very important. Okay, this is very important. Why? Because it is mentioned in the question. Okay, where it is mentioned, let me just tell you, it is mentioned that the value of receive of I would be less than require of I. In the constraint part that is mentioned, this is how I can say that I would do a certain thing and I would be getting rewarded a value less than that. Okay, please remember this condition. This condition would be true for everyone. Okay, this is now done. Now I would be removing the annotations. Now let us try to solve the question. Okay, let's say that this block is for invest and this block is for reward. Fair enough. So the very first test case was that we have here 2, 2 and 3, and here if we do that job we would be rewarded with 1, 1 and 1 itself. Okay, now I would change the color for a better visibility. Now if you observe that initially I have 3 amount with me. Okay, so I can take either of this to invest. What I can do is I can take either of this and everyone is within my reach. So if I have a value of 3, I can take either of them to do it. Okay, so I would just translate the same in Hindi for Kailash. Okay, so the question हमें ये बोलना चाह रहा है कि हमें एक काम दिया जाएगा. ओके, अगर वो काम हम लोग कर ले तो उस पर कुछ पैसा इन्वेस्ट करना होगा. वो काम खत्म करने के बाद हमारे पास कुछ रिटर्न आएगा जो उस इन्वेस्टमेंट से कम होगा. Like if we are investing 2, we would be getting 1. If we are investing 2, we would be getting 1. If we are investing 3, we would be getting 1. Okay, fair enough. No, I won't be showing code because that would be absolutely very null and void. Okay, so now see. Okay, so now see, with the value as 3, what I can do is I can take up this. Okay, I need to invest 2. So first I need to invest 2 with now I have a value of 1. Okay, and I did one job out of it. Okay, and I can do the same job multiple number of times. Okay, and then if I am done with that job, I would be rewarded with a value of 1. So now 1 plus 1 would make it 2. So now currently I have 2. Now again I can take the same job, or I can, let's say I would take the next job. You can take the same job also. Okay, So I have 2 rupees and it is required 2 rupees. So I would do the next job. Okay. I would be rewarded with 1 rupee. Okay. I would be rewarded with 1 rupee. So earlier I had 2 rupees. I have invested at 2 rupees. After doing that job, I would be getting 1 more rupees. Now, at this point, I can do no more jobs because I have a balance of 1. And with a balance of 1, I can't take this job, I can't take this job, I can't take this job. None of the jobs can be taken at this point. That is why the value 2 is our answer. Okay. Now let us take one more and we are done with that. Okay. Let's take the second one. So I would just remove this part. Okay. So I would be writing 4 and 3 and I would be having 1 and 1. Okay. And how much money I have with me? I have 3 with me. Okay. So by having a balance of 3, the very first one I would go to consider this one and I won't be able to do it. Okay. At this point I won't be able to do it. And the very next one is this one and I have a balance of 2 and I can do it. So I would do this job. Okay, I can do this job and I would be rewarded with 1 and my balance would be there and I would have received 1. Now with a balance of 1, I can take neither this job, neither this job. So I can do only one job. That is why the answer to this is just 1. Nothing more, nothing less. Okay. So am I clear with the problem statement? What is this question all about? What is this all about? So first tell me if I'm clear with this or not, quickly. Then I would just remove all the annotation. So I would be waiting for the next 1 minute. Quickly tell me if this thing is clear or not. Then I would move forward to what is observation, what is this all about, and then we would talk about that. Quickly tell me that if this thing is clear or not. Quickly, quickly. Clear? Okay, thanks a lot. Okay. So now, if you see that I can do the same job again. So the first few observation was same job can be done again. Okay. Done multiple number of times. Okay. Same job can be done multiple number of times. This is the very first observation. The very next observation is that if I want to do maximum number of jobs, okay, then I should like which job we are doing that doesn't bother us. We are only concerned about the number. So let's take a scenario. Okay, suppose I know that my class teacher told me that this is homework 1, which would take 1 hour. This is homework 2, which would take 2 hours. This is homework 3, which would take 3 hours. Okay, and she has told me to complete either of one of the homework. So the most easiest solution what we can do is we need, suppose if my teacher is only concerned about just one homework, like the quantity, she is not concerned which I am taking, but she is only concerned about how many I am doing. So if this is the scenario, then I would simply go to this homework which is taking the least amount of time and I would do it. Okay, I would do this job with the least amount of time. So now that is why what I can do is the most optimal approach for this would be that, and I can do the same homework again, like same homework can be done multiple number of times. So I would take the cheapest job. Okay, so first I would take the cheapest job. Now, what do you mean by cheapest job here? Here we are told something else. Here we are told that you need to invest something and you would be getting something less. Okay, so the amount or the price of a particular work would be investment. Okay, whatever is the investment. Suppose I am investing 5 rupees and I would be getting 3 rupees. Okay, let's say I'm investing 5 rupees, I'm getting 2 rupees. So the cost for me was, like, I invested 5 and I got 3 back. Okay, so the cost for me to do this job is 2. So in the same manner, the cost of a particular job is investment minus the return. This would be the cost of a particular job. Okay, this is the cost. This is the particular cost. Okay, that I need to do. So am I clear till this point? Like, same job can be done multiple number of times. What is the cheapness of a job? What is the amount that we spend in a job? What is the cost of a job? Am I clear with these all points? Just give me a quick one. Okay, now I would say that I would take up the cheapest job, do it, then I would keep doing it until it is cheap for me. Then I would go to the second cheapest job, and then I would again do it. But there is a small catch in this. Okay, the small catch in this is, suppose I have 10 rupees. Okay, I have 10 rupees, and this job requires an investment of 100 and it gives a return of 99. This job requires a investment of 10 rupees and this returns me only 5 rupees. Okay, so if I just, the cost of doing this job is just 1 and the cost of doing this job is just 5. Okay, still we can't do this job. Okay, this job can't be done. Why this job can't be done? Okay, this job can't be done because the investment is more than whatever we have. Okay, so this job can't be done because the investment is lot more. So this job can't be done. So we need to consider that investment should be less than whatever we have. Okay, or less than equal to whatever we have. So the very first concern is to do the cheapest job, I understand. Okay, so do the cheapest job, but respecting the constraint that investment should be less than equal to what I have. Okay, so if Geek does a job again, will he lose point? Yes, again the same investment is required. Okay, suppose I have 5 rupees and it returns me 3 rupees. If I do the same job, I would require 5 rupees. Next time also I would require 5 rupees. Next time also I would require 5 rupees. So it doesn't concern me. Okay, fair enough. So now that is why we need to do something else at this point. Okay, what else can we do? So let me first remove it. So this all is done. Okay, so now I can say that what I can do is, at each point the sorting won't work. Why sorting according to the cheap won't work? Because it might be a scenario that even though the cost of a particular job is more, okay, still we can't afford it. So what we could do is this sorting thing. First one is we would sort. So sorting won't work. Why? Because of this scenario. 199, 10 and 5. And what we have is 10 rupees. So this scenario tells us that sorting would definitely give me a wrong answer. Okay, that is why sorting can't be done at this position. Okay, so if sorting can't be done, what we can do? Okay, why sorting can't be done? Let us see why sorting can't be done. Sorting can't be done because the requirement is changing at each step. Okay, what we have is not fixed. Okay, sorting can't be done. What are the problems that we have if we do sorting? Okay, let me just show you. Sorting can't be done because what I have is dynamic. What do I mean by dynamic? It is changing. What I have is changing at each step. This is the problem. So if the elements are dynamic and we need to sort it, then we need a dynamic sorting, like it should sort at each step. So if the problem would be solved by a simple approach, that is, if we sort at each step. So if we simply sort at each step, the problem would be solved. So sorting at each step is nothing but using a priority queue itself. Okay, that is why we would be using a priority queue instead of sorting to do that. Okay, so am I clear with how this priority queue came in? Now the idea is very simple. We would calculate the cost or the cost of each job. What is cost? Investment minus the return, that would be the cost, and we would insert everyone into the priority queue, and now we would just check if the investment is less than equal to what we have, and then we would simply choose it. So give me a quick one if this thing is clear. Yep, sorting would also work, to be honest. Like if you like, what is the constraint? Like you need to iterate, you need to keep on iterating. Okay, but priority queue approach is more easy, like it is more intuitive, like it is just one sort. Yes, to be honest, just one sort is also like what he is trying to tell us. Let me just tell you the same scenario again. So earlier I told you that this is 199, this is 10 and 5. So what he would do is he would simply take up this job and then he would take up this. So can we do it using DP? Yes, many solutions are there. Absolutely, many solutions are there, and you can do it in either of the ways. I just try to tell you the most intuitive, or if I had solved up this problem in a contest, then what would be have been my approach? Could you dry run? I have solved using DP and binary search. Yes, you can do it. Like what you can do is at each step, you have done sorting because the ordering of the job is not necessary. So let me just explain you some more approach and then we would move to the priority queue approach. So what I can say is the ordering of the job is not necessary. If the ordering is different, it can be the way. Okay. So the ordering of job initially doesn't bother us. So what we do is we simply sort it. Now at each step, what we can do is we can simply do a lower bound or upper bound. Okay. Lower bound or lower bound only, not upper bound. Lower bound, and you would be able to solve it. Am I referring to the same thing? Parmar Piyush Mantilal? Am I saying the correct one? Give me a quick yes or no. Parmar Piyush? Okay. Fair enough. So just Parmar, can you quickly tell me? Okay. So now I would be moving on to the implementation and it would make more sense. Stop the screen sharing. Share the tab itself. GFG's. This one was GFG's new game, no? Yep. Investment and return. Okay, so this was I was just when I was thinking I was just writing down all the observation that I have. Okay, so I would just make it this lowercase n and this as lowercase g, and this require as req and receive as rec. Okay, and this one would be done. Now I would be having priority queue. Okay, and the priority queue, as the name suggests, would consist of two elements. Priority queue by default is sorted on the basis of first element. So I would have priority queue of int comma int. Then this is the basic syntax of this pair of int comma int. To like the default priority queue is a max heap, but we want the lowest number to be on the top, so we need a min heap. Okay, that is why we do this. Okay, and then we have greater of pair of int comma int. Okay, and then we would have pq. Okay, this is done at this point. Now we would iterate on the code itself. For int I is equals to 0, I less than. Now this, what is this command? So this command is nothing but priority queue in C++ STL. If I just show you, so this command is taken from this. Okay, instead of int, so instead of this one, instead of int, I have just replaced it with pair of int comma int. Okay, see, if I just remove up this one, if I just cut up this one and I write int, it would be the same thing. Okay, okay, or let me just paste it. So let me just copy it. Mhm. GFG's new game, share this tab instead. So I copy pasted what was there. Okay, and I wrote just PQ. Okay, now I would start pasting what was there. Okay, pair instead of intent, I would pair of int comma int, pair of int comma int, and pair of int comma int. This is how I wrote the earlier approach. Okay, I think it should be clear. Sorted map is also enough. Anything works. Okay, pq dot push, and I would say require of I, like investment minus whatever I am receiving. Okay, and I would also say that I would also need a constraint of what is the investment. Like cost is bothering me and the investment is bothering me. So I would say require of I, and I would simply push everything in there. Now the answer is very simple. We would start with answer is equals to 1. Okay, and now I would say I would keep doing this until I have money. Okay, and I have some task left on the priority queue. Okay, that is PQ is not equal to empty. Okay, now I would say pair of int comma int. Okay, first I would take out the current element. Okay, PQ dot top. So I would take out the front one and then I would do PQ dot pop itself. After doing, I would see how many, like what is the how many jobs I am able to do. Okay, so I would say int getting is equals to g minus cur dot second plus cur dot first. Okay. So whatever I have money, first g dot second, that is the required. I would remove the required money. So what I was doing before doing a job, I would first pay the investment. So investment is now drowned. What is the profit that I would be getting? Profit that I would be getting is this. So I'm getting this. Now this would be what would be left after this. Okay. And then I would divide it with current dot first. Okay. This would tell me how many jobs I can do. And then I would subtract with, I would be able to do this many jobs. So I would be, so number of jobs multiplied by the cost. Okay, multiplied by the cost, I would be able to do it. Okay, and number of jobs, if we are number of jobs we are able to do it, so I would just add it up here. Okay. Mhm. PQ dot top. And in this I would say if G is greater than equal to, if the current amount I have is greater than whatever investment is required. If the current amount of money is greater than whatever investment I have. Okay. Mhm. Okay, if the current amount of money is greater than whatever investment I have, else if this is not the scenario, then PQ dot pop itself. Or else what you can do is you can just take PQ dot pop outside also and put solve the purpose. Okay. So either of the scenarios we are doing PQ dot pop. So you can just take it out and it would be more simpler to understand. Either of the scenarios we are popping that out, and this would also work. Sorry, I mistakenly hit CTRL surface. At the end, I just need to return the value of answer itself. Now let me see how many errors I'm doing. Seems like no errors on the sample test case. Okay, I got an AC. So priority queue is simple and easy to understand. That is why I did with priority queue. Still, you can use sorting also. You can use binary search plus DP also. Anything you can do. How did you get that line? G minus C of second. Okay. G minus C of second and cur dot first. So what is G of second? Okay. What is G of second here? So let me just write it here again. And here I would be replacing. Okay. So cur of second is what? Cur of second is requirement. So here I would say whatever is the requirement. And then cur of first is what? Cur of first is my return. So this is return and this one is again return. Okay. And this I would tell that how many jobs I can do. Okay. Cur of second is what? The minimum requirement, the minimum requirement, the minimum cost, and I would say the return divided by the number of returns I can have, and that would give me the correct answer. Wouldn't have thought of using a priority queue in my whole lifetime. Mm, okay, fair enough. A person who is like, I find DSA people more comfortable with not segment trees, but bit one, the bit representation of segment trees. That is fine. Line number 43 to 46. Can you explain once again? 43 of 46. Okay. Mhm. Mhm. Okay. First, I would remove this and then I would talk you about this. Mhm. Okay, line number 43 to 46. So let me just present my screen. Remove present screen, and it is window, and this is done. Okay. So now let's understand this, of course. Okay, what is this all about? So now, first, what we are doing at this step is, first we are seeing, like we already know at this point, we already know that investment is less than equal to what I have, because then only I have a if statement of words. Okay, then only I would be able to do this. Okay, this is done. So now we move to the next step, that is that how am I calculating? So I can do the same job multiple number of times, I have been told. So what I'm doing is, the amount of money I have, I subtract it with the investment. Okay, then after that, after everything is done, I get the output result to the answer. Okay, like this is what gets returned. So this is what, like let's say I do 5 rupees job and I get return 3 rupees. Okay, so what I can do is, suppose I had 6 rupees, so 6 minus 5 plus 2. Okay, that would be 3. Okay, so 5, so if I have 6 rupees, I would be investing 5 rupees, I would be having 1 rupees, and then I would add 3 rupees. Okay, this is how we are doing that. Okay, fair enough. So now let me just, okay, so now this is done. So this was the derivation of the very first one. So this one is done. How we are getting up this one is done. Now the very next step is that how many cost I would have. Like let's say the cost of doing a particular job is 5. The cost of doing a particular job is 5, and then I have a return of 3. If I have a return of 3, then I can say that the cost, like the cost of doing this would be 2. Okay, because if I'm investing 5, 3 I'm getting in return. So cost is 2 multiplied by number of jobs I can do. I can do. This would tell me the total cost. Okay, that is why we are having this. Okay, now this thing is clear. Now this next thing is also clear. Okay, and whatever at the end we need to save, return the number of jobs, return the total number of jobs done. That is why we are adding up this. Okay, now do I make sense? line number 43 to 46. But requirements would cancel with negative if we return. No, there is a bracket in between. See, there is a bracket. No, we are dividing it. No? We are dividing the amount. We are dividing that amount. Here we are dividing. So suppose I have 100 rupees and I do 2 rupees job. So I would be dividing it. 250. Okay. I'm dividing it. It is not -3, negative return. So if you observe closely, I'm removing the annotations. Okay. Here this is subtraction, this is addition, and this is division of the whole. This is not negative. You are writing it a little bit wrong way. Okay. Now let's move to the last problem. Okay. Okay. So now the last problem is a very interesting problem. Okay. How it is interesting, let me show you that also. Okay. We are told that we are given some numbers. Okay. We are given the price money. Let's say amount of money is kept. Let's say a money is kept. Let's say 1 rupee note is kept, 2 rupee note is kept, 3 rupee note is kept, 4 rupee note is kept. Okay, let's see. Okay. Now after this point, there are two teams. Okay. The team are team 1 and team 2. Okay. So now it is telling us that if team 1 takes, like team 1 would do the first step. Okay, now it is told that team 1 would come and pick up a note. Team 2 would come and pick up a note. Team 1 would again pick up a note. So like they would do this ordering. Like first team 1 would pick, then team 2 would pick, then team 1 would pick, then team 2 would pick, and this would keep happening. Okay, fair enough at this point. So now, if team 1 and team 2 would pick in this fashion, but there are some constraints. The constraints are that if I had picked up a odd initially, like a odd value last time, then this time I need to pick up a even value, like the opposite parity thing. Okay. Okay, I need to pick up a even value currently. If I, the same manner, if I had picked up the even value last time, then this time I need to pick up a odd value this time. Okay, this is the condition that is given here. So basically, you need to just reverse the parity. Last time you took a odd, this time you need to take an even, this time you need to take an even. So now earlier we are given 1, 2, 3, 4. Let's take the scenario that team 1 has the very first option. So it first selects a even value. Okay, let's say the case 1. Okay, let me write case 1. C1. Okay, C1 starts with that it would take an even value. Now both the team would try to maximize the amount of money it is getting. So if A is taken an even value, he would first pick up 4. Okay. Now this is case one of this also. So first case one is that he is taking an even value and this person is also taking a even value. Okay. So now if this person, now 4 is gone. If this person is also taking an even value, then it would take up this one. Okay. That is 2. Now last time he has taken an even value. So this time he needs to take an odd value. So this time he would again take the maximum of whatever is odd. So he would take 3. Okay. And team 2 has no options left. So he would take a value that is 1. Okay. So this time team 1 can make 7 and team 2 can make 3. Okay. Out of this. Okay. If the first operation is done. Now, both would take optimally. What is the next step? The very next step is this time a reverse would happen. Okay, like one instead of 1, 2, 3, 4, I have 1, 2, 3, 4. This time also he would take the even value, and this time this would take the odd value. So even value, so he would definitely pick up the largest one. He would pick up the largest one, that is 4. And he would take the odd value this time, that is 3. Okay, so he took up, so this is done, this is done. So he took up a even value. This time he doesn't have any option. He needs to take up a odd value. The only left odd value is 1. And last time he has taken an odd value, so this time he needs to take an even value. So, and he has only one option only, so doesn't matter, so he would have to. So this time they both have 5 and 5. If they both play optimally. If they both play optimally. Now this time, let's take one more scenario, last scenario. I know this is getting bored a little bit, but still, this would help you in to get all the test cases. Okay, now 1, 2, 3, 4 again. This time he has decided that he would take the odd value, and this time this has decided that he would take the even value. So this is not optimal because he has taken 3 in spite of 4 already there. And so 3 is now done. So now he has taken 4. So he would take 4. Okay, 4 is now done. Last time he took an odd. So he would take even this time. So he would take this up. Now he is left with, earlier he was even. So this time he would take an 1. So now this value would be again 5 and this value would be again 5, etc. Okay. But out of all this, the answer is only 5 for team 1. Okay, for team 1 the answer is 5. But we saw that if team 1 is taking a different value, it can have more than, like, we can make team 1 win. But it is told that both the players play optimally. Whenever you are told that both the players would take the best decision, then you need to consider that each player would take the best decision at each instance. So whenever you are told that it would play optimally, both would play optimally. Whenever you are written this, you should always understand, that it is trying to tell you that player, each player or team would take the best decision, each player at each instance. So let me write this in red. This would make more sense. At each instance. Okay. Each player would take the best instance of whatever is given. Okay. Do I make sense till this point? Just give me a quick yes or no. Give me a quick yes or no. Now, till the point you are telling me, I know I'm going very slow, so I don't expect someone to get confused at each step. Okay. So now I can say that there are 3 4 cases where this person won't be able to understand. Like this is team one. Okay. Mhm. This is team one. Mhm. This is team one, and this is team two. Okay. Now there are 3 4 instances. The instances are team one can start with the even number, and team two can also start with an even number. Second instance is team one would start with the even number, but team two would start with an odd number this time. Okay. What if team has to take even value and there is no even value? Then 3 odds left. What do we do in that case? So in that scenario, team has to take an even value, so he won't be taking a chance. Like he would be getting 0 added. It is mentioned in the question that if he is not able to perform an operation, his chance would get skipped, but he needs, but like I need to take even value, so it doesn't help that I skip chances or I don't skip chances. That even condition would remain true. It is not told that if you skip one chance you are able to get the same parity. It is not. The parity thing is absolutely very solid at this point. Okay. So the very next step is, if this is even, then this is even odd. So there are 2 options only, even or odd. So either team one can take an even value, okay, and team two can take an odd value again, okay, and this time team one can take a odd value again, and team two can decide to take even value again, okay, even, odd, even, okay. This is what is there. So these are all the 4 cases that can happen. Apart from this, we have no cases other than this. Okay. So do I make sense? So now we need to cater just all this 4 cents. And now the idea is very easy. Okay. How it is easy? That if I like, these are the 4 cases, this is done. Now let me explain the idea also. The idea is very easy. Like suppose I need to take I need to take up the first step. Okay, I need to take up the first step. And I need to take up a odd value. Let's say I need to take up an odd value. If I want to take up an odd value, there is no point in taking a lower odd value. I would definitely take the maximum odd value that I have. So I would take up the maximum odd. Like in spite of team 1, in spite of team 2, I would do this only. Now the very next thing is that if I'm taking an even value, so I would do the same, max of even value. Okay, this one would be the same thing that I can do. Okay, now let me just remove this. Okay, so now the idea is very simple. We need to have 4 cases. We need to have 4 cases, and then the very next idea is that even if there is odd or even, we would take the maximum of odd or even at each step. So I would take the maximum amount of odd and even at each step. Other than this, the whole idea, like see, the idea is very simple as there are four cases. Now, the most easy scenario is that you handle all the four cases explicitly, okay, by iterating four times, okay, by doing it four times. Or what you can do is you can take help of a recursion, and you can say if it is 1 then it is the case for even, if it is 2 it is the case for even odd, if it is case 3 it is odd even, if it is case 4 it is odd, and that would solve the purpose. Okay, fair enough. This is what you can do at each step. Okay, so now I would be moving forward to the implementation. Rest is all an implementation problem. You would be able to understand it when I start implementing it right away. Okay, so I think I can move forward to the implementation. If I can move forward to the implementation, give me a quick one in the chat. Give me a quick one in the chat if I can move forward with the implementation. Mhm. Okay. So now, as this is a very long implementation problem, and it would take me around 2 or 3 minutes to implement this, like not 2 or 3 minutes, 10 to 15 minutes to implement this. That is why I have copy pasted this, because it is the same thing. We are writing four if statement. Okay, statement 1, statement 2, this is the first case, this is the second case, this is the third case, this is the fourth case. So every case we are just handling it again and again. So instead of that writing four cases individually in the recursion step, I'm just explaining you the test cases itself. So what I'm doing is, initially I need to segregate the odd and even. So first I make a vector of odd and even. Then I insert the even in the even, and which is not even, I insert it in the odd value. Then I sort it in the decreasing order, because if I want to take an odd value, I would take the maximum odd value. If I want to take the even value, I would take the maximum even value. Okay. Then I am passing on all the values, like this is the case 1, this is the case 2, this is the case 3, and this is the case 4. And the 0, 1, 2, 3 is telling the recursion what kind of case it is. Okay, because we need to consider all the four cases. Okay, and it would give me what is the value of team 1, what is the value of team 2, what is what. Okay, okay, a simple thing has been done. Okay, sorry. Yep. So first we need to segregate the odd and even. So first we are segregating it to the even, like all the even values are kept at even, all the odd values are kept at odd. Okay. Then we know that if I want to take an even value at this instance, so I would take the biggest even that is possible, and I would take the biggest odd that is possible. Okay, that is why I am sorting it in the reverse order, that is in the decreasing order. So the first one would be the maximum odd, the second one would be the second maximum odd, the third one would be the third maximum odd. Okay, then I'm getting the values of all the four cases, like which I did in the sample test case. Sample test case I did for everything, and then I told that the answer is 5. Why the answer is 5? Because they both have the same position. Okay, so these are all the four cases. Let us say what is in the recursion, we would see to it, but let us first understand. Okay, if the difference is less, then only it would consider as an answer. So here instead of team 1 and team 2, it is Alice. Okay, it is Alice, and the next person's name is Bob. Because in game theory problem, it is a very common technique that the first one is referred as Alice and the next person is taken as Bob. We are always told that Alice and Bob are playing a game. Alice and Bob are playing a game. That is why people, problem setters, are most accustomed to this. Okay, so instead of team 1 and team 2, we did Alice and Bob. And the thing which is having the least, then it is the answer for that. Now let us see what the function if recursion is doing. Now the recursion is a very cunning. Okay, the recursion is cunning. Why? Because if the even size is less, here this time both needs to take even. So case 0 is for even and even. Case 0 is for even and even. Now we come to case 2. Okay, which is even and odd. Okay, this case is for even and odd. Okay, here we are just assigning Alice to 0, Bob to the odd value, and then we are doing that. Okay, then the very next time is odd and even odd is done. So this time we would be doing odd even, and this would be done at this point. Okay, and the very last one is, of course, even is done. The last one is odd. Okay, at this step we need to take two odd, but so at each odd and even we are having this kind of thing. What is this? So let's say we want, so if both needs to take an even value but the number of even value remaining is just 1, then we are returning -1. Okay, if we need even and odd but either of them doesn't have, like I need to take even and he needs to take an odd, but odd is not present, let's say, or even is not present, or both is not present, then we would return -1. In the same scenario, if I need to take odd and even, the same thing. If I need to do the same thing, I would do. Now here we are assigning the values. Like if Alice wants to take an even value, he would take up the very largest even that is possible. Bob would take the largest even that is possible. Okay, if Alice needs to take an even value, he would take the largest. Okay, at each step. Now at the next step, it is telling us the parity. Like if even is taken, next time we are passing it 1. That means I need to take an odd value next time. So if Alice has taken even at this step, the next time I am referring it with 0. Okay. So as this is the code is a long code and I won't be able to accommodate this in here. So what I would do is, instead of this, I would generate the URL and send you the code, and you tell me the point at which you are not able to understand. And copy. And this is the link. So now you need to tell me the point at which you are not able to understand. And I would just keep presented my Miro board. And here I will just remove all the annotations. So quickly tell me the point at which you are not able to understand and I would solve the purpose. Okay. Can this be condensed? Yep, it can be condensed, but beginners won't be able to understand it. Just like, let's say it is just like this. Suppose I wants to do Knight's move, okay, or Knight's move. It is 0 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2. So if I want to move in all the 4 direction, there are two ways I can do. Either I can use 8 if statement. Either I can use 8 if statement, Or I can just add 0, 1, 1, 0 and 0, 0, 1, 1, and I would be able to visit all the four direction. So in the same manner, this can be condensed, but it would make a little bit difficult for beginners. That is why I am not willing to do it, in spite of the code being long. Okay, but you can use bit to do this. So now share your doubts. I would say share your doubts for question 3 from code link. Okay, so now this is done. Okay, I would be waiting for the next 1 minute. So now, okay, so now there have been a little bit of instance where you thought that I'm going very slowly. It is because today I am not using my pen tab. Okay, I bought a new iPad to just draw everything, and I'm drawing everything in the iPad itself. But this is my first day, so I don't want it to affect the stream. That is why I thought that I would take it a little bit slow, because if I take little bit fast, because I'm also getting acquainted with the system. If you just observe, many a times I need to adjust the board many a times, but I tried to make it as flawless as possible, because drawing on a iPad is much more flexible and the handwriting is absolutely great and we can do a lot of things and it just feels like paper. Okay, till this point I was using the pen tab to do it, but from now I would be using the iPad. So make sure you tell your views on this. If you don't like this thing, I would be back with the pen tab thing. Okay, so this was just a step to just initialize a better approach, and I'm also thinking of doing something of my own, like starting off a YouTube channel or a course or something. That is why I thought of this. Okay, so that's it. So if you're watching the stream in the recorded version, feel free to comment on the video and like on the video so that this reach will be increased. So that's it for today. Thank you, everyone. Okay. Bye bye, everyone. Good night.